So the topic is what properties of math. Yeah. Okay. So we've got a lot of concepts here, so you must know this definition for the purpose of the test and exam. So the first one is this one. They're explaining what is but wherein the main idea of this topic is to explain the elasticity of material. So I'll explain what is elasticity. So we have the first concept here, the rigid body. So a rigid body is a body on which the 2 points never changes whenever a force is applied on it. Practically, there is no rigid body. Okay, so what they mean by rigid body in simple terms is an object which by if you apply a force on it, a force on it, it won't change. It will remain the same. Its shape, it will remain the same. Its shape or the size will remain the same. So that's a rigid body. Then we have what we call the deformed body. So this one obviously is the opposite. Is the opposite of a rigid body. So a deformed body is defined as a body on which the 2 points changes under its spin of some forces when applied on it. And then they say the study of this property is of this body is called what? Elasticity. So elasticity, here we're talking about an object which by if it's subjected under a particular force is gonna change. It's either it, it's either the, the shape changes in terms of what? In terms of the length or in terms of, let me write here, in terms of the length or the volume or obviously if the shape is changing, we can also say the area uh, and what else. Yeah, but let's talk about the length and the volume and also this one, the area. So that's why we're gonna have different types of modulars and then I'll explain them. So here we're having the definition for elasticity. Elasticity is the tendency of a solid material to return to its original state after the applied force is exerted on them. So this means that you are having an object, and then once you apply a force on that object, let's say it's a sponge. Obviously, it will change the shape, but the moment you release that sponge, you stop applying the force, it will return to its original state, just like uh, this ribbon here. There are examples of elastic material, a rubber is fine. Any type of a rubber you can see there. So yeah, when the force are removed, the object will return to its initial shape and size if the object is elastic. And then they say steel cables, rubber bands. So these ones are example of what? Of elastic material. Elastic material. So these are examples of elastic material. And then we have a concept called stress. No? So stress is the force applied. Uh, so you must also know this definition. It's important. Yeah. So I was saying that elasticity and what else? And this one and stress. No? And also what's the other one? Strain. Uh, uh, But for now, the most important definition, the one for elasticity, must know is for the purpose of the test. It's either they ask on the multiple choice or they ask you in the long question. You must be able to state it is the tendency of the solid materials to return to their original shape after an applied force is exerted on. Then we have what we call stress. So stress is the force applied uh, or system of forces that tends to deform the body. Okay, so this one force per unit area. Okay, so when we talk about stress, we're talking about the amount we're measuring is the measure of the force being applied on an object per unit area. Per unit area. That's why we have this definition here. An arrow will be having an object. Let's say we have an object, whatever object it is, and then we apply a force on it. So the amount of force that we're exerting is called stress. So we're measuring the rate at which this object is deforming or changing. So the formula is force per unit area. The stress, think here the symbol is alpha. Is it alpha or sigma? It's sigma. They are using sigma. So sigma is equal to force per unit area. So whenever you see this, you must know that okay, now we're talking about stress. I can also just know this one. The types of stress is that we have normal stress, tangential stress, bulk stress. So this usually comes in multiple choice. Multiple choice. They usually bring this. You must know the type. Okay, one of the normal stress, compressive stress. Yeah. So another thing that you must know is the difference between tensile stress and compressive stress. You must know the difference. So with tensile stress, I think tensile stress is the stress that occurs when the surface of the body is loaded by a linear force, where and then they say where F is the axial force, what due to the extent that is the length of the metal tend to increase in the tensile direction. Or here we have an object. I don't know if this thing is like this, giving the calc examples, you won't be able to understand. Okay, let's come to this diagram. Let me understand. You see, a force that is being applied into the object. This one is what? Compressive stress. Then tensile outside. I will check the simplest definition because I think here they are not explaining them proper. So for this one, we'll say tensile because the stress is being applied outside the object. Mm. That's why here they're saying is the tensile stress is the stress state leading to the expansion. That is the length of the material tends to increase. So with tensile stress, what you have to know is that the length will increase. The length will increase. And then I was still to get you.
Yeah.
Okay. And then with compressive stress, the length will decrease. The length will decrease. That's why the thing is the stress that leads to the decrease in the length. So the length will decrease. Let's start. Suppose trigger stress result is in machine. Also, this thing is a machine. So yeah. Conditional stress, intense stress, to be an economic and stress. Okay, so with this one is also important. You must understand it. What's the shear stress? So the unit for shear stress is what? It's not actual lambda, but it looks like lambda. So shear stress is a type of tangential stress, no? A type of tangential stress. So the question is what changes on on uh, on shear stress and what changes on bulk stress. So you must be able to understand that. Let me check for not keeping anything. Tangential. Oh no, we're skipping this one. No, there are three types of stress. No? We have tangential, we've got shear stress, and we also have bulk stress. So with tangential stress, the formula is what? Why don't I see the formula? Okay, with tangential stress, I don't know the unit for tangential. I think it's lambda. I think they're also using lambda. I think this one, the formula will be changing x over changing e. So here we're experiencing change in height for tangential stress. You must know the formula. And then shear stress, here we have a change in what? For shear stress, we have a change in the area, in the area. We're talking about the change in the area of the object. And then with this one for bulk or volumetric stress, so this two is the same meaning. This one was talking about the change in the volume of our object, of our object. Uh, shear stress, shear strain. We can also have what we call shear strain, no? Or what we call strain. So let's start here. Strain. Well, stress, we've got strain. So you must be able to differentiate. So with stress, we said we're talking about stress. We're talking about the amount of force being experienced by the object. And so now we come to the concept of strain. So the unit for strain, why you are using E. You guys are using E. The thing is the change in the shape and size of a body due to the deforming force. Changing dimension. Okay, so stress is what? Changing the dimension over the original dimension. Perfect. Now I explain the opposite. So what happens here? Let me see something. Here, stress. Uh, force is being prior to just if you try to cause one layer to multiply. Yes, and then I have something like. So I think what I was explaining here for stress is actually for strain, not for stress. Not sure if yeah. Because if you check here the same type of strain, then they say since the deformation force can produce three types of then there are three types of strain. Yeah. So we've got longitudinal strain. This one is responsible for the length. So we'll go back to those ones I already explained them. Then this one is responsible for the area. Yeah. So let me check. Yeah, our one. Hence we've got this one for longitudinal strain. We've got this formula. A longitudinal is changing length over the original length. Then volume changing is what is volume changing V over V. And then sharing
Saya kukombeni stream.
able for the
Aya
no,
kukombeni
not
stream
length, the shape
yesiteli.
of our object.
Screen na xi vona mara se u mutini.
Perfect. Okay, well, it's fine. Now, this is so far. Uh, so what I was saying, hey, while I was busy explaining down there, let me go back to what I was saying. I was saying that we've got three types of strain and also three types of stress. So let me start with strain because this one is straightforward. Types of strain, we've got longitudinal strain, volumetric strain, and shearing strain. Then I've already explained that longitudinal is responsible for length, this one volume, that one for area. And these ones are the formula. So the question now is, what is the difference? Because now we also have this one, the types of stress. So this is required an opposite of in the horizontal. So yeah, I think there is a relationship here, but anything else, you just see. So do you know the relationship between stress and strain?
Uh-uh.
And I think we started late to teaching. Shear stress, force per unit erecting parallel, lateral displacement pair. Okay, these things are actually are not the same, but similar. It's problem. Our meeting is gonna end, and I don't know if we'll be able to continue. Let me try to write here. So let me try to write the difference. No, no longer have enough time. We have got three types of stress, and also I've got three types of what? Of strain. So for strain, I've already explained. We've got the longitudinal strain. We have got what? Volumetric or bulk, or what we call bulk. And we've got shear strain. And I've explained those ones. So with this one, we've got shear stress, which is represented by lambda equal to force per unit area. This one is checking what the force per acting parallel to. We're checking the force that is acting parallel to that object. Force acting parallel to, let me say, to the surface of that object. And then we've got shear strain. This one we're checking the amount of force on how what well on the what on the displacement of that object. So let me write the formula as well. So what we call here, no, what's this? Oh, I already wrote shear stress. So I've got what now? Okay, now I've got to call tangential, no? The one that we begin like tangential stress. Uh, the other one is the three. Tangential stress. Yeah, so this one is responsible for the change in the displacement. When you're applying a force here, so we're checking the amount of displacement. Okay? So this is the formula. No? Lambda equal to change in x over h. Then we have, what's the other one? The last one is just, bulk stress. So what is the formula for bulk stress? Yeah. Oh, it's this one. We have what we call bulk stress. So this one is responsible for the volume, right? As well. Bulk stress. P, so here we use P. Notice correctly the difference, there is a difference also with the, I think with the variables being used. Yes, F over L. On that other one, for string, for bulk string, we're using a different, we're using a different variable. We're using E, changing V over V. But on stress, we're going to say P equal to F per unit A. Although we're checking for the same thing. So you must be able to differentiate. So this one, I can see if you are task, you must be able to differentiate when check the difference between strain and stress and be able to explain it to someone. So what's the difference? This one could be a task check. So now let's go to, I want us to check the formulas that you must know in order to calculate. Okay, what type of modular? Yeah, we must start here. Okay, this term called elastic modulus is a measure of stiffness of the material. So this definition is important. Where elastic modulus, which is also called Young modulus, this one is also called, another term for this is Young modulus. So we're checking the stiffness of the material. So the formula is stress over strain. So already know the formula for stress and already know the formula for strain. So these are the types of modulus. Young modulus of elasticity, we have got bulk modulus of elasticity, and also have what we call shear modulus. No, okay, I said the modulus of elasticity is the same as Young modulus. No, it's not the same. This one is just a concept introducing us to what to elastic modulus. So we'll be checking the stiffness of all the elastic materials. So that's why we've got these types of modulus of elasticity here. So, but the formula for Young modulus is the same as that one. So I'll show you, I think it's down here. Yeah, this one. So the difference there, you see, they just added normal. Here they added longitudinal. If you remove this, you will see rho is the same as this concept, modulus of elasticity. So this one it has a unit. So you must also know the unit. So y is equal to, you know that stress is force per unit area all over uh, all over stress is changing L over L. Change, not stress, strain. Okay, let's see. Change in L over L. So that's the formula, right? For longitudinal strain. You for Young modulus. This is the formula. So you must know it. They might not give you in the chest. And then and don't forget, we must write it in this way. Don't say stress over strain. They might penalize you. Write it in this way. Normal stress over the longitudinal strain. Okay, the second type, obviously this one it was derived, right? This one was derived from that. Then the second type of modulus, okay, that I will explain later on, and also the examples